not be there. She pinged me. Shubham, I'm not sure. Sai Chandana, I think she's also having some exam or something like that, so she will not be there as well. Not sure about Abhishek and Shubham. Okay, recording has been started, so they can refer it. No issues. We shall proceed. Let me share my screen. One second. Can one of you confirm when you are able to see the screen?
Yeah,
Yeah,
Anshuman,
we
it's
can
Yes,
see it.
Anshuman, we can.
Awesome. So, uh, guys, today's session, luckily, uh, was expecting this that the Matillion would be up. I mean, it doesn't really go down for that long, but was the case yesterday. But for today, it will not be. It is not the case. So good for us. We can proceed. So I will be covering some of the topics which we have seen over the slides, which we couldn't cover in yesterday's session. So let me start with that. So as you know, this is the console of Matillion, and we would go to the project. We'd go to, sorry, Mat session is what we have created. So let's go there only. And we would try to make new job. So we faced an issue with the load generator, S3 load generator. So we'll try that again and see if we are able to, create the table through that job. So let me create a orchestration level job. Oops, it's not typing. One second, guys. Second org job. So whenever you guys will be working on any of the project, you would have to make sure that the naming convention for that project has been followed. Or let's say if you are starting a new project only, then in that case, there would be a standard naming convention guide that, okay, how we want to keep our jobs. So it's easy to read, easy to access. And if at all some new member is joining and supporting that project, he's also able to understand it. So it should be simply like a three-stepped name or a two-step name with information about uh, a brief information about what we are trying to do here. So, I mean, I'm just keeping it simple as of now because this is our second org job only. So let's switch to this job. We know this is an orchestration job by just looking at this component, the start component. And let me do the S3 load generator component. So as soon as we pull the S3 load component to the canvas, we can see that it opens its properties panel right away. So let's go to the S3 bucket, select this same file only, get sample. Okay, next. So we know the file is comma delimited, correct? We can see it here. So we'll provide the comma delimiter property as uh, in the field delimiter like configuration portion, and we would uh, we can increase the size as well if we want. Mhm. Order number we can make it as 10, purchasing amount 20, For date, if you want to keep it as varchar, we can do it. But if we want to see what is the date format here, we can go back and see that in what format the date is. So it looks like it is DDMMYYY. So let's try that in the functionality here. We change it to date. Customer ID will do 10. Salesman ID will do 10. Okay. And table name would be orders orders underscore test two. Let's test it. If we are able to see the data as it is, yeah, looks like we're good. So create and run. So as soon as we run it, it automatically creates this create table component. So we'll drag it here and we connect it to start component if we want this component to run in this flow. So once we have added it, we'll go to its properties. It is taking the same table name, column names, etc. Uh, so here we have to, it is saying that this table doesn't exist. So first we would run this component only so that this table is created and then we will do the load. So let's run this component. It's like this table is created and we'll go to this his properties and we should be able to see order test 2 now, and it is turning to green. That means the component is in right state to be run. So we will run the entire job. Again, don't tell me that table already exists. Ah man, why you do it? Okay, so let's do a workaround on it. We will
No,
change
yesterday you had created a table of the same, the
with the same
last
name.
time. Yeah.
No, let me see here in Snowflake. With the same name you're saying?
I believe you did something with test two, so I'm not sure, but maybe.
Okay, we would check that. So which we are here using adventure schema, I believe, edit environment. Yeah, adventure role, adventure schema. So we would go there. Yes. All right. So let me go back to the project, met session, second org job, and test four. Test four. Here will so we just have to validate this component, not run the component. And once we validate the component, then we can run the entire flow, because the flow will only create the table. If we will run the component before, it will be already created, and then the st load component doesn't take it as a new table because it is already created. So we'll just validate this component. And
What what did you say? Can you repeat that?
yeah, so what I'm saying is that uh, we just gave this name. We created this. We like whenever we use S3 load generator and we wanted to create this new table, generally what I was doing is that I was running this component. So when I'm running this component, this is a create table component. So it is creating that table. But the SC load generator works when this is validated. Like, okay, this component is validated. We know that this table will be created when we'll run all of them combined. So in order to not face that error that this table already exists, we would simply revalidate it and then rerun it instead of like running this component beforehand.
Understood.
Got it? Yeah. It should work. So we have got this table created here. We can refresh it and go to Adventure DB, AW Data Lake, and we should be able to see it. So that's how we can see the data that whether this component has created the table, or we can just go to an transformation job. Second XFM job. And here as well, we can see that whether this table is having the data or not by using the component table input. So if I just use this component and give the required table detail, this is our table. We want all the columns. We don't want any offset. So if I go and sample it, we can see the data here. So this is one way to see that whether this orchestration law, like level job has created this table or not. All right. And yesterday, if you guys remember, I was talking about that how we can call the transformation job in orchestration job itself. So what it does is that we don't really have to open the transformation job. So we can just drag and drop this entire job itself. So this is an transformation job component, and if we like double click it, there'll be some other job in it. So whatever job is having like whatever workflow is there in this transformation job, if we want to run it on orchestration level, we can just call it into an orchestration job. And we can also call the orchestration jobs as well. Like let's say I want this orchestration job to run, and then I want this transformation job to run. So I can just call the jobs inside in an orchestration workflow so that those jobs runs. So this is how we generally create a pipeline. Like this is be the high level job, but whenever somebody opens this job, there'll be something inside it, and then probably if you open this, then there'll be one of like one more workflow will be inside it. So that's how we can call a number of jobs through just one workflow. That can be the master workflow, and inside it, it can call as many as orchestration or transformation job it wants. But that should depend on that how we want our data to be loaded, that which one we want to run first and which one we want to run second. Similarly, we can uh, put them here in the workflow, and by just simply running this one, we will be able to run these component as well. If I'll run it now, it will fail because we don't know what these jobs are doing. So just on how we can uh, run multiple jobs.
So Anshuman, Nadeep here. One doubt I have.
Yeah.
So while you're dragging the transformation job, we can use the transformation components too in it.
Transformation component to.
Like if you are putting the transformation jobs in this transformation job in the orchestration job,
Mhm.
so we are able to use the transformation components also.
No, this is an orchestration
Okay,
job
so
only. Even
okay,
when we
okay,
are, when we are calling it inside here also, it is an orchestration job only. So we'll not be
okay, okay.
able to do it. But
Mm-hmm.
from here, we can open that transformation job, and inside that we can
Acha,
do it.
inside that we can go and we can then use the
Yeah,
components.
because that is nothing but a transformation job only. Let's say we have
Hmm.
created this one. So if I want to open it, I can just open this job here directly, and then I can make changes here,
Okay.
and
Mhm.
those changes will be here as well because we have updated this job. So whatever this job is having should be called if we run this orchestration flow.
Okay, okay. Got it. Thank you.
No worries. All right. So this is about loading the data into cloud data warehouse and then reading it either from Snowflake or directly uh, in our Matillion workflow. Now we should move forward and do some joins on some tables and see how those can be done. So we have talked about some of the transformations as well, like there's the first transformation job. So we did like some filter or something like that here. So similarly, we'll do all of these functionality. Let me create a, so now we know that the join, let's talk about join. So join will come once we have the data extracted. Now we want to do some transformation on that data. So in that phase only we'll be like using all of these transformation components. So join is also one of the transformation component, so it makes sense that we will have to create a transformation job to use it. So let's create a transformation job to use the join component. Let's job. Say job. Okay. I'll switch project here because I want to. In this project, we are not having that many tables where we can join. So I'll use the test KT1.
To
Hmm.
join, you need uh,
You need two tables, like
and
which
with
with the
similar
keys.
one
Yeah, yeah,
common
yeah.
column, right? Huh?
Correct, correct,
Mm.
correct. So for that, I'll go with this project because here there are some jobs which are having such tables where we can work with the join functionalities. So I'll create a job here, add transformation job, join XFM job. All right, so we want to read the data from two table inputs. That's clear, right? And then we want to do a join on both of them. So this can be the basic flow. Now we just have to set the properties inside them and see that how the data is working with this. So let's set the property. Let's use the table. Mm, let me see which table I can use it. So I just check the environment information that which one it is and change it to that. Data engineer. I have to change the role, data engineer role, SF training, bank loan, and loans. So we'll use this schema here. So if we go to bank loan and loan schema, we have some tables like orders, payment, customer. These are having a relationship between them. customer, orders, payment. So we would just work around with these tables. Okay. So let me put those details. Let me show what we are giving. Let me expand it. So we'll give the target table. That where we want to read this data from. So orders table, columns, which all columns this table is having and which all column we want. Let's skip this. It is just the timestamp column that we don't want to keep it as of now. So this would be the orders table schema ready, turned green. That means validated. Same functionality we'll do with the second one. So as I was saying, customer is having the similar data. Uh, I mean, relationship between these two tables. So we'll use that. Okay, ID should be the key column. We'll call all of these, and we'll just see metadata here as well. ID, that should be the orders ID, user ID. User ID would be the customer ID. So we'll use that as the join condition. So this is join component, very similar to what we do in SQL, but just through a component. So we can assign our main table, alias, join condition, output column. So let me assign the main table. We want orders to be our main table. Just give some alias to it and then join. And let me add the condition. We want to join to the customer table, and yes, it cust. Let's do an inner join first. If we have more tables as well, we can add these and have those joins. So once first we would decide our master table, and then like bunch of the tables which we want to join it with, those we can join it, and then we are going to do the join condition, that what join condition we want. So looks like user ID from orders table would be equals to customer ID. So this is the join condition that should work for these two tables. So we would use this. Uh, we can have other functions as well if we want to do some sort of functions on the joins, like all of these functions, plus minus or string functions, and a lot of functions are there, date functions, miscellaneous functions. So that is our like condition is set. Then we want to see that what output column we want. So let's first add all, and then we can divide, like we can remove them. So order ID we can keep, user ID we can keep, cust ID. So if you see, the alias we had used has came here because the ID uh, columns are having the same name. Like we have the ID column both, but if we have given the alias, the target would be differentiating it with that alias of the like table. So let's keep all of them, and it's validated. That means the conditions are right and the stage is good. So now we can sample the data. So let's sample it. And if you see, we have the order ID, user ID, order date, status, and similar, like details like first name, last name, and cust ID has came from the customer table. So that means that, okay, we were able to make a join between these two tables, and this is an inner join. So the row count is 99 rows, quite high. Let's change that property to some other join. Let's do a left join here and come to sample and see if there's any difference in the count. No. So it looks like we are having the same IDs only on the both side. So it didn't change. User IDs are same in both tables, if you see, because this and this column is our join condition, user ID and cust ID. And it looks like same. So yeah, if we have certain tables which are having uh, like different data, we would get like different number of rows for each of the join, but for these two it is not going to be the case. But yeah, this is the join stage uh, in like nutshell. I mean, like we can say this is what we can do in join. We can have two tables, uh, read them through table input component and then simply join them. So once we have joined it, we can do any of the functions on this, like that, like those transformations from here also depends on what sort of requirement we are having. Let's say we want to do some filter. So once we have joined it, we can go and filter the data. So mm, status is equals to, we will see what is the status having. So this is such a good functionality that we can sample data directly here. And it was not the case with the previous tools in market. We would probably just load entire data and then go to the database and see. But it stages that data and gives us this functionality that we can see it here. So we see that status, we have several columns like returned, completed, and all. So we would filter the data on this condition equals to returned. We have a lot of functions here, like less than, equals to, greater than, null, blank, whatever we want to keep in the filter condition. So filter is nothing but the where clause. So we're just creating an SQL here. So filter, turned green. That means the stage is ready to be uh, worked upon. Like it is validated itself that everything is good. We can see the data in it. So these are the four orders which has been returned. So we can see, okay, these were the four orders which had this status, and filter condition was able to do it. So if we go to SQL, we can see that what this filter has done. So this is what it has done. As I was saying, it's nothing but a where condition. Similarly, in join also, we can go and see that how it has joined. So it has done a left outer join on these two tables and pulled all of these columns, and it joined on this condition. So yeah, that's a brief about join stage, guys. Any question so far?
No, Anshuman.
Okay. I think it would be same in any of the tools you guys have previously seen or worked as well. It's because it's basically an SQL concept, and all of these new age ELT or ETL tools are very much based on SQL as their base. So they are doing uh, nothing but the SQL functionality only, but through a GUI version, and you know gives us functionality to do some tough transformation, which would be a little tough to write in SQL. Makes it very easy to do it through the GUI based version of it. Makes sense? So this is about filter. Let's try other join stages. So there are a number of join stages we have. So let's try unite. We'll remove this and this. We'll do unite. So unite, as I have told, is nothing but union or union all in SQL. So we know that union will join the two tables with same metadata, and union will not give us the duplicate, but union all will give us that duplicate data. So here in unite, when we see uh, in the properties section, we can see that it also gives us an option to keep the duplicate or no. So in that way, it turns it to union or union all. Like we have that option to select. But this will not work for these two tables. Why? Because the metadata is not same. So we may have to use table which are having same metadata to see this component. Um, what about orders new? Is it having same? Yeah, yeah. So we would change this table's property, and we would instead we'll use a table which is having the same metadata, so we can see how unite will work. So we will use orders new. Now these columns will not make sense because it was for previous table. And if you remember, we have excluded this column. So if we are going to keep this column, then it will not work because it won't the metadata or the column uh, uh, the column to be the same. So we should remove this column. So we would not want this in the output. Turned green, that means that the component is ready. So orders one, just updated the name of the component and unite. So let's go to unite. So you can change the unite's name as well. Unite order, which all column we want. So we want all columns or the overlapping columns. So we would want all of the columns on, here. We want columns from both of the table and source component column. No. So the source component column functionality is, I think let's try this and do yes and see what it changes. We want remove duplicate. No, because we want to do an union all as of now. So let's do a sample on unite. So it's validated. Let's see the row count. So it is saying 206 rows. That means uh, it has combined the data from both of these order table. I'm just checking the source table properly. Add source component column. Okay, so if we are going to check this as yes, it will add a new column here, source table. That what is the source table here. If we are going to do a no, then it will just not add that new column. So let's not keep it a new. We just want to combine the data. So if we do that, then you'd see that that source column is gone. So we can see 206 rows. So let's see how many rows the individual tables were having. So this orders table is having 99 and orders one is having 107. So combined, it is giving us 206. Now we can do some other property changes as well that we don't want duplicate. In that case, the count should slightly change. See, we got 106 rows only because it is not giving us the duplicate rows. So that's how unite can be done. And similarly, intersect, we know in the set theory and generally as well in SQL that what intersect does. So it is very similar to what it generally does there. It is only going to give us the data which is not there in both of the both of these tables. So should have the intersect data only. So these are the records which are uh, not common here. So this is giving us that. That's how intersect would work. And similarly, except will only give us the rows from one of the table and not from the another one. So you can try that as well. So this cast type, you must be wondering what is it. So it is basically is when there are different type of when we are like uniting or joining two table, but their like data types are like different. So like Matillion itself try to cast them, the cast property in SQL that where we can change the data type from one to another. So it is for that. So it wants us to give a primary table that which one you want the data from only. So we would just want the data from orders. So it is giving us 0 rows. If we are going to change this to orders one, let's see if it changes. Yes, so it is giving us these few rows, like rows which are not there in orders. So what was happening that orders and orders one. So orders was having all the rows which are there in orders one as well. But order one has some extra rows which are not there in orders. That means those are the rows which are, like coming as a result when we are running this component. Sorry, here, here. So this is how the join components, all of them work in Matillion. So we can use any of them, and then going forward we can do further transformations on that per the business requirement, that how we want data to be once it is joined, intersect, or uh, union is done on that. Any question, guys?
Anshuman, can you please once again tell about accept?
Yeah. So in English term, accept means that we just want one side data. Like let's say how it is used in general talking, like uh,
It means
everybody.
excluding something.
Yes, everybody has joined except Vijay. So we
Okay.
just want that data, that Vijay data here. So
Acha, acha.
when we are doing it in terms of like tables, so when we are giving one primary table component here in like properties, so it will only give us data which is there only in this table. It will not give us the combined data from both. It will not give us the shared data which is same in both of these tables, but the
Hmm.
only uh,
Okay.
data which is here. So that's what
Got
accept is. Yeah,
got it. Thank you.
no worries. Any other question, guys? Hmm, I take that as no. All right, so we move to another component. So that component is detect change. But before I proceed, I have a question for you guys. So you would have heard of slowly changing dimension. So what is that all about? Slowly changing dimension in data engineering or data science, or I mean, what is data? Sorry, SCD. Have you heard of it first of all? And if you have heard of it, do you have any idea that what that is?
Yes, Anshuman. It actually manages both current and historical data over a period of time.
Yeah, that's correct, Sandeep. So slowly changing dimension is a problem basically, which was very common in the field of data engineering or ETL, where let's say we have some record, but over the time it has changed. For example, we had a employee who updated. So we had an employee, we had all of his information in our database, but he moved places and his address got updated. So that means that the value for for that dimension changed over the time. So how do we handle that? So uh, in like classic Bill Inmon architecture, he provided with three solutions: SCD1, SCD2, and SCD3. So these three are the solutions of handling a dimension which like which has changed over the time. So SCD1 was that, okay, let's say some employee was there, he moved, so his address is updated. So we would not keep his older address and we would just keep the new address. So that was how you handle it if you are going with SCD one solution. And then SCD2 solution was that, okay, we are going to keep both of the records, the older address as well as the newer address. That's how you handled when you're going to handle it with SCD2 solution. And SCD like SCD3 was that we update the like table in such way that we introduce a new column, something like timestamp, that okay, his address, like its address was this for this time, and since this time the address has been updated to XYZ. So those are the three solutions to handle a dimension which has changed over the time. Okay, so in Matillion or in any of the ETL tool, when we are dealing with incremental data, that means that when the data is changing over the time for a particular key, we are bound to face slowly changing dimension problems. So to handle that, most of the cases you would have heard change data capture is being done. So they basically capture that what data has been changed over the time for that particular key, and we identify that and then we handle it accordingly. So similarly here in like Matillion, when we talk about handling the dimension which has changed over the time, we use a stage. We can use a stage. We have other ways as well, but we can also use a stage called detect change. So detect change is used to handle the SCD problems. So what it does is that it matches the data from two uh, sources. One is like our main source, and one is the newer source, and it sees that what data has changed for a particular key. So it basically asks for for a like match key, which should be there in both of the tables, just like any of the join operation. On the basis of one key, it sees that whether the value for other columns have changed. And once uh, we know that okay, the value has changed, then it gives them the change codes. So those change codes helps us in like deciding that okay, whether it's a new data which has came, whether it just a copy of data, whether it is a deleted data, or uh, whether it is an update on the existing data. So that's how we use detect change. And yeah, it is highly used because it is practical and real time scenarios uses this a lot, because we would see the data changing over time for most of the dimensions. Any of the incremental loads which which we'll be doing, we will see that the data is going to change over the time. And to understand that and to see that what is being changed, we would use this component. Okay. Any question so far? I mean, what SCD is and why we are doing it.
No, Anshuman.
Okay. So so again, a prerequisite to use this column is that both of the tables should have the same metadata, which means same column structure. So we would see that if the column structure is same, so we already know that these two tables are having the same column structure. For orders, these four columns are here, and for order one, these four columns are here. So we would go with the detect change component. Let's update its name. Mm, Changes, change order details. So we want to define a master table out of the like these two. So master table in real life scenario would be the one which is basically there on our cloud data warehouse, and having all the data which has been updated so far. So in this case, it is be orders and match key. It would ask that on what basis you want to see. So we would go with ID. will match on the ID. So on the basis of ID, it will check the value of these three columns and match for both of the tables to see if there has been any changes for uh, these three columns for each of the ID in this table. Okay, so we have given ID as our matched key. We want compare columns to be these three. Mm, okay, and output mapping columns. So if you see, it came as master compare, master compare, master compare. So this we are going to keep all of them for now, but in our real time project, we can see that which all column we want to take forward from here. Okay, so it will give us the same same columns, but an additional column will come, which will be change codes. Will like tell us whether the value has changed for these or not. Okay, so indicator column, we want an indicator column, and we can update the name of that indicator column. We'll name it as change codes. So if we go and sample this data now, so we are having ID, master user ID, compare user ID. So this ID is on what basis we are matching. So it is giving us two columns for each of them, one from the master table, one from the compare table, and it has given us the change code. So it is not one. I means identical, that this has not changed. So let's see if some of them are changed. N. So N means these are new. So new means that these columns are not there in this master table, but these have came from our incremental load. Okay. So it will give us N for that. C is copy. That means these are same. Like it was, sorry, C is changed. So these are the one which has been, like updated. So for like this one, the data has been updated. uh, like out of those three columns which we used for compare, we see that okay, data has been updated here. And new would be again that these are the new columns which were not there in the master table. We don't have any column which will have change code as D. D means delete. So delete would be that we are having it in master table, but it is not coming anymore from the incremental load data, the compare table. So that will be like delete because it's not here anymore. So if you see, it has given us data for it has given us data for all the columns which are identical, all the columns which are uh, new or changed, but we don't have anything for delete because there was no such column which is only here and is not coming from our newer load. If there was any, we would have got a change code with D as well. So that's how like detect change helps us finding out that what happened to that like data like over the time, whether we have we are seeing some new rows or whether we are seeing some updates on the existing data. And the change codes uh, comes handy, as once we know that, we can do a filter here on just on basis of those change codes, and we can uh, like divide these columns as per our business requirement. Like if we want to delete the column which is not there anymore in the newer load, we can do that. Or if we want to update our like table with this updated data which has changed, we can do that. Or the new records which has came, we want to insert them, we can do that. So filter would be handy here because we can use change codes equal is equal to I. One more condition, change code is equal to N, and one more, change code is equal to C, changed. So here it is not giving us any because it is not able to see that which condition it should look for. But if we would send it to the output, we will be able to see it. Or if we just uh, keep one change condition, if I just remove this and just want to see what has changed, it should be able to give us those rows. Yeah, so one record has changed over the time. So if you are going to do uh, like use multiple filter conditions, then we would have to give it to send it to some output uh, tables or files, and we can distinguish it that okay, these are the details which has changed over the time. So this is a brief about detect change stage, which is a popular one. I'm not sure how heavily user ready has used it in their project, but I have previously worked on it. And yeah, even in other ETL tools also, some variant of it used to be there. So that's about detect change. Any question, guys?
Anshuman, can detect change can be used only in single table because one a single table also gets updated with time, right?
Mhm.
So can we detect the change in just one table?
No, we have to, compare it. It has the functionality of a master and compare. So what we can do is that single table, we can just create a duplicate of that and then compare itself to its existing version. And we can see that whether the older instance of that table and the newer instance of that table, what are the changes there on the basis of key. But if you just want to use one table and uh, not having any other table to compare with, then no, we will not be able to use detect change.
Yeah, got it. Thank you.
Okay, no worries. Any other question, guys?
And one more thing, like
Mm-hmm.
this detect changes, as you are saying, it is widely used.
Mm-hmm.
So I want to know like a particular use case scenario where this will be very useful. Like yeah, I know that it will be showing us the changes that has happened.
Mm-hmm.
Uh, but like how, I mean, it will be. Is it like beneficial for analytics purpose or something?
It is beneficial to maintain the history data and to handle the SED output. So yeah, there was a lot of background noise. No worries. So yeah, it is very the use case which I can see is that let's say we have some uh, snowflake table which is being used to do some visualizations. Okay, and we are seeing that the data is updating in that table over the time. Like we are having an incremental load. Like every day we are getting some new records. So it will help us find those new record and load them in that table. Because otherwise, if we are not having any of such CDC like compatibility options, we will not be able to find it unless we really go through the data and see what has changed. So it is basically a match on two tables that which are having same metadata, a match that which gives us the information about what changed over the time. And like practical use case is basically like any data warehouse which is having uh, like history data and some incremental data as well every day or every week or every month coming in that. So in those scenario, it would be very handy to have such a component which can tells us that okay, these are the new records which you can insert in this table, and these are the records which are not coming anymore from the source. So you can delete them because the newer versions are not having them. So you can delete them from your main table and probably keep a history of them for some time. And then after that, you can remove them as well if there is no use of it. So that's a practical use case of it.
Yeah, got it, Anshuman. Thank you.
No worries. Any other question, guys? No? Okay. So now let's talk about job variables. So basically, in Matillion, there are three main type of variables: job variables, grid variables, and environment variable. So first is job variable. So job variable is a variable which is specific to a job. Like it cannot be used in any other job if we have created a job variable in one job. Second, grid variable. Grid variable is a variable which is more like an array. Like it keeps a list of information in it, and it can call those information one by one or the way we want it. That's grid variable. And third is the environment variable. So environment variables are basically which are environment specific, like everything, whatever having uh, in this environment, whatever jobs, be it orchestration, be it transformation, we can use those environment variables in them. There's a fourth type as well. Those are the inbuilt environment variables. So if you would have seen, we saw it, manage environment variable. Let's go to a component. So there are some of the variables which are already there, like job ID, project ID. All of those are the pre-built environment variable which Matillion provides. So those are there as well. Just trying to see where I can see them. It's not here. It will only show the one which we have created. Mhm. Yeah, we can see them later. No issues. I'll see where we can find them. But yeah, let's talk about environment variable first. Sorry, job variable first. So which are like job specific variables only. So we can only call them in job. Like before talking about what they are, you should also know that in Matillion, the each variable has two type of behavior. One is shared, one is copied. So when we are going with the copied behavior of any of the variable, that means that we can only use those variables, be it environment variable, be it grid variable, be it job variable. We can only use them in that version only. So whenever you will be working on a project, you first thing you will be doing is that you will be, like creating your own version. Okay, so whatever code base is there and you want to make changes on that, I'm not sure how it will be for a small project, but let's say there's a big project where already we are having some jobs created which are running on daily basis and we don't want them to be messed up. So it is recommended that we create our own, like versions of it and then just work on our version and then, like merge it later to the uh, final version which can be in like pre-prod environment and then finally go to prod environment. So when we are having those versions, so the like variables are like also having those behavior. So when we are just when we are just keeping it as copied, that means that this variable will only be there for our version which we have created. But if we are giving it as shared, that means it will be there for the all versions of that project. And we have this behavior property for all of the variables, all like three which I have mentioned. So we we can leverage it as per our requirements, that if we want uh, these variables to be our version specific only, or we want them to be universal and be used by anybody. So we can do that. Okay. So let's create a variable. Uh, what is the job like? Okay. So we'll create the environment. We'll try to like call this database through a variable. So we'll create a variable for database. It should be text. We are going to keep it copied because we just want it in our version. Visibility, we'll keep it public. If we'll keep it private, that means even in the same version, the others, like people will not be able to reuse in these variables in their jobs. So we don't want that. We want it public. And value DB name, I think, is bank loans DB. So I'll give this value. So this is created. Now I want this database. Instead of this database, uh, I want that variable to be called here. So I'll do use variable. And so these are the environment variable which are already there, which I was saying. So component ID and all. But we also see our one, which is DB name. So you see job has validated with it. So job took this DB name uh, as a variable. So like this is required and it will be used because we don't want these informations to be directly be there. So here we are using environment default because we know what environment we are connected to and we can see, okay, these are the details for that environment. But if you are working on a bunch of projects and you don't really need, like you don't really remember it, in that case, you will have to use the variables. So uh, like this is how we'll use variables for each of these like standard or like standard component properties. And each variable will be having this dollar sign and then quotes, unquote, sorry, like braces, and then in braces it will be having the DB name. Similarly, we can create it for like schema. So we'll do that. We create for schema name. And schema name is loans. So we're keeping properties as same and let's save it. And we go back here and if we want to use that variable in this job, just click on use variable and we would be able to use schema name here. See, component is still validating because it is having the required information. So same we can do for this job as well. Sorry. Makes sense. I mean, how it is able to validate the job, and there's no issue which we are having because it is having the required information of that connection, database and schema. So we are able to validate these component, and even if we run the job, it will be fine because components are already in like green state. So even the run was finished fine. So that's how you can use the job variables. And similarly, you can create environment variables. So environment variables should be created from here because these are environment specific. So they will also be having the same property, and the default value will be there for the environment, the entire environment. So whatever jobs are going to be there in that environment will be having uh, this environment specific value. And when we talk about grid variable, uh, as you see, we can give a list of like values here in this one, but the properties are exactly same, but it can have a number of values and like column names. So let's say if to uh, we want to give all of these details, for example, this table name, column name, all of them through environment, like through some variable. So in that case, we would be using a grid variable. We'll see the practical approach of grid and environment as well. But for now, we'll keep it simple till job variable. I just told you the brief that, okay, what those variables are all about. But yeah, they're very easy as well, and like pretty much similar to job variables. So whenever we'll be like working in a project, you would see the use of variables very like very freely because they make sure that the data is kind of encrypted and we are not able to see the name directly. So it doesn't show us that what is the DB name, what is the schema name is there, and it's a good it's a best practice also to use variables. So variables, like they are called variables in like Matillion, but in other uh, technologies, you would have heard of parameters. So they are very similar to parameters. I mean, they are a synonym only of parameters. So we just call them variables here. And uh, yeah, they provide us four type of variables, but the fourth one is the pre-built variables which come already with it. But the three which are there, we can create them. Any question on variables, guys?
So this is mainly for security purpose, right? Like just to
Yeah,
hide the.
for encrypting it.
Okay. Yeah.
All right. Any other question, guys, so far on the session?
Anshuman, just curious to know that
Mhm.
I mean initially you that after table input there was one more thing, multiple table input. What it does
Mhm.
basically?
So multiple table input. So here we are using like one table, okay? But if we want similar kind of tables to be used, like which are having similar naming conventions and similar data, and we want those to be so there's a pattern here. So we can define this pattern that, okay, we want all the tables which are like orders underscore star. So it will have no table of this. So basically, it is used to call a number of table at once, but we should have the naming conventions similar here. So in this schema, we are not really having any of those tables. So, but it should still call some of them. Ta, 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 ta. Order. So sometimes we have a table structure like, okay, we have orders 2021, 2022, something like that. And we want them to be called like some uh, only some value changes after this. So those can be used by multi-table, like component. but the name should be very similar to them. So without a common set of name, we cannot call multiple tables. But if there are common set of names, then we can use them.
Yeah, Anshuman, actually, I got it. Yeah, got your point.
Okay.
Like the way we use in Snowflake, like when we download or we upload the file, so we give a pattern that this is the same kind of file.
Yeah.
Yeah.
Correct.
Correct.
Similar.
Yeah. Similar. Yeah.
Okay. Okay. Any other question, guys? All right. If no, then we would wrap today's session and we would continue in the next. We are little over the time already, so and we were late as well, 1 hour late. So I don't want you guys to uh, stay here on your Friday evening for late. Shall we wrap up? Any question?
Any question? No
No,
question.
Anshuman, all good from my side.
my side.
Okay. Thank you, guys. Thanks for joining. I will see you on Monday. Have a nice weekend.
Thank you, Anshuman.
Yeah, thanks.
Have a great weekend.
Thank you. Have a great
Bye bye.
Bye bye.
Bye.